Hi, everyone. I'm Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois, and I'm here to do the AP Daily Practice session for CS Principles. We are going to get this going in just a moment, but I want to remind you to go ahead and click the link in the video or in the video description to access the PDF that will have all the items we are going over today. So in this review, we're going to focus on Big Idea 3, algorithms and programming. Let's get started right away. We have this code segment. And so let's take a peek. Consider the code segment below. Which of the following changes will not affect the results when the code segment is executed? So we have if A equals 0, we'll do B is assigned A plus 10, otherwise B is assigned A plus 20. So I want to know which of the following changes will not affect the results when the code segment is executed. So if I change line 3 to B is 10, well, that's only executing if A is 0. So 0 plus 10 is 10. So that should not have an effect. But just to double check, if I would have changed line 3 to A is B plus 10, well, A then would change to some value. I don't know what B is, but it's going to be some value. So it's going to change the value of A. So that does have an effect. If I change it to B is 20, well, if A is 0, B was supposed to be 10. Now it's 20. That does have an effect. So we have another issue. Line 3 here changing to A is B plus 20 is a problem because that's also changing A. So I know that letter A has to be the answer because B and D choices change the values of variable A, and line C choice changed the value of variable B. So our answer is A. If you want to review if-else statements, you can look at the 3.6 daily video number 3 in AP Classroom. All right, so let's get some loops in here. In the program below, y is a positive integer such as 1, 2, 3, etc. What is the value of result after running the program? So result starts at 0. We're going to repeat whatever's inside this large box 3 times. And what's in this smaller box or rectangle, I'm going to repeat y times. So we can see our choices are y plus 3, 3y, y cubed, or 3 to the y power. Now, when I look at this, there's a few things that I want to make sure I'm aware of. Y will be a positive integer, so I don't have to worry about 0 or negatives. Okay, and I also want to keep track of a result. That is the main thing. Notice that result gets updated by 1 every time we go into the inner loop. All right, so knowing that, I want to go ahead and figure out what is going to happen. Remember, this outer loop will repeat 3 times. The inner loop will repeat y times. Now, some of you might be noticing, well, if I have an outer and an inner loop, they will actually repeat then their product. So that would be 3 times y. But maybe you didn't notice that. We'll try putting in a small value for y, like 2. So if y is 2, the first time I'm in this outer loop, I'll go in here and I'm going to add 1 to result 2 times. So result started at 0, it'll become 1 and then 2. Now I repeat a second time and do 2 more times. So it'll go up to 3 and then 4. The third time I'm repeating this 2 times, it'll go up to 5 and 6. So 3 times 2 is 6. So maybe you noticed that it was a product. If you're not sure, try plugging in small numbers and see if you can determine an answer from that. If you want to review tracing code with iteration, remember iteration is another word for repetition, or in our case, loops. You might want to look at 3.8 video 3 in AP Classroom. All right, question 3. Programs 1 and 2 below are each intended to calculate the sum of the integers from 1 to n. Assume that n is a positive integer, again, like 1, 2, and 3. Which of the following best describes the behavior of the 2 programs? So before I look at the programs, let's look at the answers. Program 1 displays the correct sum, but program 2 does not. Program 2 displays the correct sum, but program 1 does not. Both 1 and 2 display the correct sum. Neither 1 nor 2 displays the correct sum. So remember, we want the sum from 1 to n. Again, I would suggest plugging in a small number for n. Let's plug in 2. If you plug in 2, the sum of 1 and 2 is just 3. All right? So I starts at 1, result starts at 0. I'm going to repeat this 2 times if n is 2. So I add 1 to result, which makes it 1. I becomes 2. I'm going to repeat a second time. So I add 2 to 1, result becomes 3. I actually will become 3, but now I've already repeated 2 times. I display the result, which is 3. 1 plus 2 is 3. That was the sum. That works okay. So I know that program 1 works. So I know that D is not an option because 1 could work. Oops, kind of got ahead of myself here, but that's all right. Let's check program 2. If I is n is 2, the result starts at 0. I'm going to repeat 2 times. Result becomes result plus I, so I was 2. Result becomes 2. I now becomes 1. I'll repeat a second time. I add 1 to 2, which makes result 3. I becomes 0, but my 2 times of repeating is over, so I'll display the 3. So in fact, 1 and 2 both do display the correct sum. So make sure when you're looking at this, if you know how to do sums, you might have been able to just look at the code. If you're not 100% sure, again, plug in a small value for n and see if you can use that to help you figure out what your answer will be. In this case, once I knew that 1 did work, I could have eliminated B and D, but definitely D. If you want to review sum and product algorithms, 3.8 Daily Video 2 will go over those algorithms for you. All right, now we have a robot question. So the question below, use a robot to move along the squares. The robot is represented as a triangle. So we can see this triangle here, okay, which is initially in the bottom left square of the grid and facing towards the top of the grid. So you can see that here. Code for the procedure mystery is shown below. Assume the parameter P has been assigned a positive integer value like 1, 2, or 3. So notice P is a parameter. I'm going to repeat move forward, and rotate right P times. So I want to know which of the following is a possible result. So could I get the robot facing to the left in the bottom row? Could I get it facing in the second to the top row towards the right facing down? Could I have it in the same spot at the bottom left facing down? Or could I have it directly in the middle of the grid facing up? Well, what I'm going to do is just start repeating. So if I repeat 1 time, if P is 1, I would go forward once and then turn to the right. There is no option here that shows the robot facing the right in this square, right in the middle in the first column. So I'm going to have to repeat a second time. So remember, I'm facing right. I go to the right 2 times, move forward twice, rotate right again, which will have me facing down. Okay, well, no place do I have that. I do have, letter D does have the robot in the middle, but it's facing up, not down. So I'm going to repeat again, go down and then face to the right. So remember, from going down to the right is actually going to have it facing what looks like to the left, actually. Notice that is what's in A. So A is my answer. All right, because that's a possible result. It didn't say what's the result because I don't know what P is. So this, I just have to look to see. If I had it 4 times, I would go forward twice and move right. It would just go back to this first where it started. So I actually, if I just keep repeating, will eventually keep making a square. And the only one that ends up with one of the options, no matter how many times P times is, the only one that's a potential option is A. None of the others will end up. I never end up here in B. And C, I end up there, but I'm facing the wrong direction in the answer. And in D, I end up there, but it's facing the wrong direction. So in this case, you just have to start one at a time until you find one of the repetitions that ends up looking like one of your answers. Review the exam reference sheet so to make sure you're familiar with the robot pseudocode. Number 5, the following code segment is intended to set max equal to the maximum value among the integer values x, y, and z. The code segment does not work as intended in all cases. Which of the following initial values for x, y, and z can be used to show that the segment does not work as intended? So let's look at A. I want to show this does not work as intended. So if x is 1, 1 is X greater than Y? 1 is not greater than 2, so I won't execute this. I'll go into the next if. Is Y greater than X? Yes. Is Y greater than Z? No. So I'll go into the else. Max is 3. That's right. So that shows that it works. If I do the next option, 1 is greater than 3, X is greater than Y, that's not true, so I won't do the first if, execute the first one. Is Y greater than X? Yes, 3 is greater than 1. Is Y greater than Z? Yes, 3 is greater than 2. So my max is Y, and that's correct. For 3, X is greater than Y. 2 is not greater than 3. So I'm going to go into my second. Is 3 greater than 2? Y greater than X? Yes. Is 3 greater than 1? Y greater than Z? So max is Y. That's okay. Let's look at D. X is greater than Y, so 3 is greater than 2. And X is greater than Z, so 3 is greater than 1. So max is 3, but I'm not done because there's an if. It's not an else if. So this if is still going to execute. 2 is not greater than 3, so I'm going to go into the else. And max is now going to be replaced with 1. So instead of actually giving me the maximum, it's not. It actually gave me the smallest number. So in this case, we want to know what does not work as intended. And we want to find the code segment that did not work as intended. All of those worked. A, B, and C. D did not work as intended. So that shows that the code segment is not correct. And next one, the procedure mystery below, the parameter number is a positive integer. Which of the following best describes the result of running this procedure? The procedure returns true if the initial value of number is 2 and it returns false otherwise. The procedure returns true when the initial value of number is greater than 2 and otherwise returns false. The procedure returns true when the initial value of number is even and otherwise returns false. The procedure returns true when the initial value of number is odd and otherwise returns false. So remember, we have a parameter number and we know it is a positive integer. All right. Now, if number is 2, I'm going to repeat because it's not greater than or equal to or less than or equal to 0. 2 minus 2 is 0. So now number is 0. I'll check number is 0. That returns true. So I know 2 will return true. But what about 3? Well, 3 minus 2 is 1. I'm going to have to repeat this again. 1 minus 2 is negative 1. Negative 1 is less than or equal to 0. Now I check. Negative 1 does not equal 0, so I return false. Okay, so 3 seemed to work as where it returns false. 4, I'm going to subtract 2, and I get 2. I subtract 2 again, and I get 0. Number is 0. It'll return true. So it will return true for numbers other than 2. So A does not work. Will it work when the initial value of number is greater than 2? Well, it does. It'll return true when the initial number is greater than 2. It did for 4, but it returned false for 3. So that did not work. For C, does it return true when the net value is even? Well, it worked for 2 and 4, and I think that's going to keep happening because even numbers will always give me 0 when I subtract 2, but odd numbers will eventually get to negative 1. But if the initial number is odd, it returns true. What we saw when the initial number was 3, it returned false. So our answer is C. Again, 3.13 daily videos 1 and 2 will help you look at procedures. Last question. Find the maximum value in a list of 1 or more integers. Consider the 2 versions. So we're going to look, we want to look, is it both are correct? 1 works correctly, but 2 only works correctly when the maximum value is not the first value. 2 always works correctly, but 1 only works correctly when the maximum is greater than or equal to negative 1, or neither execute correctly when the input is positive and negative. So if I look at this for algorithm 1, set the value of the variable max to negative 1, iterate through the list of integer values. If the data is greater than the value of the variable max, set max to a data value. Well, in Chicago, we have multiple days that are below 0. So if all my numbers are like negative 20, negative 30, negative 25, negative 1 will turn out to be the max, but that wasn't even the temperature on a given day. So if I set it to negative 1 and all the values are below negative 1, it's not going to work. So I know algorithm 1, there's 2 versions here, but algorithm 1 does not work, so that gets rid of A, and it also gets rid of B. check algorithm 2. If I set it to the first data value and then look at the rest of the integers, if it's greater than the variable max, set max to the data. This will ensure that I find a maximum value. So algorithm 2 will work. So we know that C is the answer. A programmer is deciding between a linear or binary search, which is true. We have a sorted list here. In all cases, a binary search requires fewer comparisons than linear. Generally, the advantage of using a binary search over a linear search increases as the size increases. A linear search will generally run faster than a binary search because a linear search requires fewer lines of code, and using a linear search is preferable to using a binary search. All right, remember, linear would be starting at the first spot and looking at each one. Binary, you start in the middle, as long as it's a sorted list, and we keep dividing in half, so we keep cutting out half of the numbers. So in all cases, does it require fewer comparisons? No. If it happens to be the first number, linear is faster. A linear search does not run faster than a binary search generally, because usually we can cut out half of the ones we're searching for. And if it's not found, we'll actually use less searches or checks than we will in a binary, because the binary only has to check half of them. So B is correct. In general, the binary does actually have an advantage if the size of the list increases. Again, if you want to look at binary search, look at 3.11 Daily Video 1. Thank you for joining us today, and I hope you look at some of our other videos. Good luck on your exam.